Welcome to Engage Math, Lesson 22, Problem 3, where we are simplifying rational expressions. Just as a reminder, we can only cancel factors. We cannot cancel terms. So you can't just say, oh, I have an x squared over an x squared. I'm going to cancel that. Can't do it. They are terms. Once we get factors, we can cancel. So this is going to be all about factoring. So let me start by zooming into each problem because they take a little work and it'd be good for you to be able to see it really clearly. So 3a, we're going to first start by factoring x squared minus 49, which is the difference of two squares. So it's x minus 7, x plus 7. Makes no difference if you prefer to say x plus 7 first and x minus 7 second. Let's go to the denominator. Remember, your first step in factoring is to take out a greatest common factor if possible, and it certainly is possible in that denominator. Okay, let's go to the 4x plus 8. Once again, we have a greatest common factor. So I'm going to take that out before anything else. Now in the denominator, it's x squared plus 9x plus 14. There is no GCF. It is a trinomial. The leading coefficient is 1. So the great news is it's a simple AM problem because it's a trinomial with a leading coefficient of 1. All we have to do is to think of which numbers add to 9 and multiply to 14. So we're going to get x plus 2 and x plus 7 because 2 plus 7 is 9, 2 times 7 is 14. And the great news now is we are ready to cancel. Even though it's a multiplication problem, you are allowed to cancel across these two fractions because with multiplication, we could technically just do that if we wanted to. It means the same thing because the numerators would just get multiplied and so would the denominators. So here I go. The x plus 2's cancel. Great. X plus 7, they cancel. This is actually kind of fun, I think. X minus 7's, they cancel. Our final answer is 4 over 3, and we are done. What a simple problem. Not a simple problem to do, but the answer is so much simpler than the original problem. So it's really great to have this skill. It just will simplify so many things for you. Okay, B is a light bulb. So these are tough enough, not to mention that now we have a light bulb. So let's do the numerator of B. And what we're going to have here is x squared minus 9 times x squared plus 9. There was no GCF, so I knew it was the difference of two squares, and that's what we have to start with. In the denominator, the leading coefficient of this trinomial is 1, so all we have to do is think AM again. All right, so the two numbers that multiply to 15 and add to 8, x plus 3 and x plus 5. All right, that part is done. Now I have times 7, not much we can do with the 7. But this is interesting because there is a greatest common factor, but I also know we don't usually see the number and then the variable. And I can actually tell that if we want to have this factor, 9 minus 3x, in a form where it's going to cancel with something from the numerator, let's rewrite it with the x first. So what I'm going to do is I'm going to factor out a negative 3. And you're going to see why when I do this, we are not changing the form. We're changing the form, but we are not changing the expression. So let's take a minute for this because it's tricky. This is the same as what I just wrote down there. Because if you were to distribute that negative 3, you would get negative 3x, check. We have to have a minus 3x. And negative 3 times the minus 3 gives us a positive 9. So the great news is we have now rewritten 9 minus 3x as a negative 3 times the quantity x minus 3. Totally allowed to do that. And the great news is, I'm going to get rid of this extra arrow thing now. And the great news about this is we are now ready to see if anything else can be factored, and then we're ready to cancel. Now, if you look at all the things that you have, all the factors you have in the numerator and denominator, only one that I see can be factored again because we have the difference of two squares again. So I'm going to take the time to write this out again just to make sure I don't lose you on this. But that x squared minus 9 factors as x minus 3 and x plus 3. The x squared plus 9 does not factor again. It's only the difference of two squares that factors, not the sum of two squares. So now I'm just rewriting this. Sorry, it's taking a little while, but it's going to be great in a second because we are going to have fun canceling everything. Let's change the color to be really dramatic with this. Okay, X minus 3, gone. How about X plus 3? Gone. And by the way, the reason we can cancel is they basically, a factor over itself is just has a value of 1. So let's see, we are ready for our final answer now. So we have 7 times the quantity, x squared plus 9, over negative 3 times the quantity, x plus 5. By the way, it doesn't matter if the negative sign right here is in the top, off to the side, or in the bottom. You just want to make sure you've only written it once. Okay, let's go to C. We're rolling. All right, another, oh, wow, we have another light bulb. So there's a lot, but let's go to C and we'll do the next light bulb. All right, x squared, it's the difference of two squares because there is no GCF. So we're going to go directly to the difference of two squares, and I'm kind of rolling through that now, knowing you know the difference of two squares. So x to the fourth minus 10,000 can factor as x squared minus 10 and x squared minus 100 and x squared plus 100. In the denominator, we have a GCF, so I'm going to write 3 times the quantity, x minus 10. All right, then we have times. Trinomial with a leading coefficient of 1, it's simply an AM. So it's going to be x plus 10 and x plus 1, the two numbers that add to 10 and multiply to 11, and x squared plus 100. A little tricky, but it doesn't factor because it's not the difference of two perfect squares. Okay, I'm going to change the color again so that we can see what can be factored again. And again, I only see one thing that can be factored again. The x squared minus 100 can be rewritten as x squared minus 10, x squared plus 10. Everything else is just going to get rewritten. Okay, so I'm going to take the time to rewrite it just to make sure you see everything. Let's make that 3 a little bit better. 3 times x minus 10. And then it's still going to be times x plus 10 times x plus 1 over x squared plus 100. And I'm going to put the x squared plus 100 in parentheses just so we know we tried to factor it and it didn't factor, so we don't get confused with that. Okay, let's see what factor or cancels now. X squared plus 100 over x squared plus 100. How about the x minus 10 and the x minus 10s? Not as many things as I was hoping for, but we are ready for our final answer now, which is going to be x plus 10, the quantity to the second power, times x plus 1, that's everything in the numerator, just over 3, and we're done. This is our final answer. Okay, let's go to D. Okay, so for D, we're going to look first at the numerator 6p squared, etc. I think, though, just to be really clear, I don't think it's a bad idea to rewrite this problem first as a multiplication problem. I just don't want you to forget what we're doing here. So as you know, when you are dividing two fractions, it's keep, change, flip, which we have done. So all I did was keep the first fraction, change it to multiplication, and then to flip the second fraction. Now we're ready to roll. So in the numerator, it's going to be not an AM problem because the leading coefficient is 6. It's a trinomial, but it's not a trinomial that can be factored really quickly because of that 6, that leading coefficient not being 1. We can't just do an AM. So just to remind you, the way we do this, and I'm going to kind of do it off to the side here, I'm going to just kind of show you this in green so you know that that's kind of what I'm doing over here. So 6 times negative 12, you do A times C, which gives us negative 72. And the two numbers that multiply to negative 72 and add up to the 1, even though it doesn't look like it, there's a 1 in front of that P, as we know. So the two numbers that add to positive 1 and multiply to negative 72 are 9 and negative 8. So let's rewrite that. We're going to split the middle term. So what we're going to do is we're going to say, and by the way, I'm only working on the green part right now, 6p squared plus 9p minus 8p minus 12. The way we split the middle term is we now take the GCF from these first two terms, which is 3p. So we have 3p times p plus 3. And then here I have minus 4. And once again, oh, sorry, I forgot the 2 there. There should be a 2. I hope you caught me on that. So 3p times 2p plus 3. And then when I take out the negative 4, I get 2p and once again plus 3. The way I caught my own error is I knew that these two parentheses had to match. I'd like to tell you I did it on purpose to see if you were paying attention, but it's not true. So Now we're going to take out our GCF, which is 2p plus 3, and 3p minus 4 is what's left. So we are going to take a minute now and rewrite that numerator, and everything else we're going to factor. Okay, so keep in mind that this quantity right here now is going to be what's going to replace that numerator. So off to the side here, I think I'm going to go to a different color again, except for I'm going to leave the green for that numerator just to make sure you see. So our new fraction of, the multiplication fraction is going to be, I'm going to kind of put a line right here so you can see where I'm going. I'm going to just move right up there. So what I have is 2p plus 3. So 2p plus 3 times 3p minus 4. Okay, and then I'm going to take out the GCF from here. So what that's going to be is just a 2. So I'm going to say times 2. So I'm just going to put the 2 there. And, sorry, it's a little hard to see all that. 2 times 3p plus 4. I'm going to take 1 minute, sorry, and just rewrite this quickly for you so you can see exactly where we're going with that. So let me just do that really quickly and make sure you can see where I'm going with that. Okay. So that last one. Okay. So I'm going to write a lot smaller, and I'm just going to say it's 2p plus 3, and then it's going to be 3p minus 4. Okay, and then I'm going to take that 6p plus 8, and I'm going to write that with a GCF taken out, so it's going to be times 2, and then inside we have a 3p plus 4. So let's just make that a little bit more legible. 3p plus 4. Sorry, not very legible there, though. Okay, so now that is all going to be over the 7 from here. And then we know that 9p squared minus 16 is going to be 3p minus 4 and 3p plus 4. Okay, now's the fun part. Let's kind of cancel, especially because this is a little messy, so I'm looking to cancel. So 2p plus 3 does not cancel, but 3p minus 4 cancels, 3p minus 4. 3p plus 4 and 3p plus 4. So in the numerator, we simply have a 2 and a 2p plus 3, and in the denominator, we simply have 7, and we're done. All right, let's go back to the original screen so you can see everything together. And I apologize again for squishing that in there. All right, have a great time doing more factoring, and thanks for joining us at Engage Math.